Hey guys, we will look at a concept called relative speed. See, the question of a relative speed arises when you have two bodies moving together at the same time in the picture. I will explain this concept through a simple example. Let's look at two cars, say C1 and C2, which are initially at a distance of say 200 kilometers apart. The cars are starting to move together at the same time with a speed of say this car being 20 kilometers per hour and the other one 30 kilometers per hour. So you have two cars at a distance of 200 kilometers apart and they are starting towards each other at two different speeds, say 20 kilometers per hour and this one 30 kilometers per hour. Obviously, they have to meet at some point in between after some time. Can you guess after how long they will be meeting at this point, say, supposing on the assumption of these two cars meeting at this point after whatever time they take, can you calculate the time after which they meet here at M? See, every 1 hour, these two cars are coming closer to each other by how many kilometers? See, every 1 hour they will be traveling together 50 kilometers. So after 1 hour, they will get close to each other 50 kilometers. After the second 1 hour, another 50, third another 50, fourth another 50. So after 4 hours, they will be getting close to each other by 200 kilometers, which was actually the distance they were initially apart. So what does that indicate? After 4 hours, these two cars will be meeting at this point. Now, to find out that, all you have to do is look at the initial distance the two cars were apart and take the sum of the speeds of the two cars, which is 20 plus 30, and this will be 200 by 50, and that's equal to 4, or rather 4 hours. Now look at this 20 plus 30 is actually what? They travel in 1 hour. It is this sum of their speeds what we refer to as relative speed of the cars C1 and C2. So when you have two cars moving in the opposite direction, sum of their speeds is what we mean by a relative speed of the two cars. So you take the total distance and divide it by the sum of the speeds, or rather relative speed of these two cars, to find out after how long they will be meeting at some point in between. This is how we define relative speed when you have two bodies moving in the opposite direction. Now there is another case when you have two cars moving in the same direction, and how do you define relative speed? Look at this example. Take the same two cars, say C1 and C2. Let's assume they are at a distance of 40 kilometers. And here you have two cars moving in the same direction. This car moving at say 60 kilometers per hour and this one 50 kilometers per hour. So you can visualize the case of two cars here. There are two cars 40 kilometers apart. They are starting to move together at the same time, both in the same direction. One at 60 kilometers, the other at 50 kilometers. See, obviously if you have two cars with one car moving faster than the other car, it's like this car chasing this car. And obviously, the car being chased is slower than the other one that's chasing it. They have to meet at some point somewhere here. Let's assume they meet up at some point here. Can you find out after how long these two cars will be meeting at this point here? See, look at this. In every 1 hour, the distance between the two cars is getting reduced by the difference between their speeds, which is 10 kilometers. In every 1 hour. In the next 1 hour, again the distance is getting reduced by 10 kilometers, third hour, fourth hour. So after 4 hours, the difference between the two cars is getting reduced by 40 kilometers, which was actually what the distance between these two cars initially. So what does that indicate? The cars are meeting after 4 hours. So to find out after how long one car will meet up with the other car, all you have to do is take the initial distance, divide that by the difference, rather the higher speed minus lower speed. This will be 40 by 10 and that's equal to 4 hours. So initial distance is divided by the difference between the speeds of the two cars, which is 10 kilometers, and you can arrive at that. And this difference, rather the speed of the faster car minus the speed of the slower car, is what we refer to as relative speed in this case. And that relative speed is 10 kilometers per hour. So this is the case of a relative speed when you have two cars moving in the same direction. You take the difference When you have two cars moving in the same direction, you take the sum of their speeds as the relative speed. This is the idea of a relative speed. We will work out a few simple examples to get a better idea of this concept called a relative speed. This is a simple problem based on the concept of relative speed. The problem is this: a car starts from A to B at 5 a.m. and reaches B at 11 a.m. Another car starting from B at 6 a.m. arrives at A at 10 a.m. At what time did the cars cross each other? So we don't know the distance between A and B to move from A to B. How many hours does it take? 5 a.m. to 11 a.m. means 6 hours. And the second car starting at 6 a.m. arrives at the other end point A at 10 a.m. That means it takes 4 hours. The distance, as I said, we don't know between A and B. You can go in for a variable or simplify the problem. Let's take the distance as the LCM of these two figures. Why I take the LCM, you will get to see when I am done with the problem. What is the LCM of these two numbers? 24. So let's assume 24 as the distance between A and B. The first car, let's name it X. The second car, if the distance is assumed to be 24, you can work out the speeds of the cars. What will be the speed of the car X? That will be 24. It's taking 6 hours. So distance by time, that is 4 km per hour. This is the speed of car X. Again, speed of car Y will be 24 by, it takes 4 hours. So distance by time is speed, which is 6 km per hour. So we got the speeds of the cars as 4 and 6 km per hour. Now there is one more problem here. Car X is starting at 5, whereas the other one is starting at 6. So in the concept of relative speed, we have to have both the cars starting at the same time. So what do? If you look at the position of, supposing, say, this is at 5 a.m. At 5 a.m., the second car is not there in the picture. The first car is here with a speed of 4 km per hour, started already moving, but the car Y will come into the picture only at 6 a.m. Now look at the position. This is the position at 5 a.m. Now look at the position at 6 a.m. At 6 a.m., this car has traveled how many hours? 1 hour. And its speed is 4 km. Can you see this? 4 km. So where will be the position of X at 6 a.m.? Somewhere here. And the car Y comes into the picture here. It's moving with a speed of 6 km per hour. And car is here with 4 km. And initially it was here. So how much is the distance covered by car X in 1 hour? That is 4 km. Because when you say the speed is 4 km per hour, speed is nothing but the distance covered in 1 hour. Rather, it covers in 1 hour 4 km. So total distance between A and B, total distance is 24. 4 already covered. Now the remaining distance is 20 kilometers. So this is the position of the two cars at 6 a.m. They are 20 kilometers apart, and X is here, Y is here. Now you have brought the whole idea to the position where you can apply the concept of relative speed, because you have two cars starting at the same time, which is 6 a.m. Now, and we know their speeds. Obviously, they have to meet at some point in between. We are asked to find out the time it takes to meet at this point. At what time did the cars cross each other? The same thing only. Okay. Now, what do you do in such problems? You look at the initial distance, or rather the distance when they have started moving towards each other at the same time, which is 20 kilometers. It's not 24, it's 20 kilometers. Now, what do? You divide that by the sum of their speeds, which is 4 plus 6. This is the relative speed, because the cars are moving in opposite direction. And this will work out to 20 by 10, and that's 2 hours. So the cars are meeting after 2 hours. And this 2 hours you count not from 5 o'clock, but from 6 o'clock. Because at that position only, the cars are moving towards each other, starting at the same time, which is 6 a.m. So the cars will be meeting or crossing each other at 8 a.m., which means 6 plus 6 a.m. plus 2 hours. That's 8 a.m. This is the time after which they cross each other. So we have covered the concept of relative speed and also one problem based on that concept. If there is anything you fail to follow correctly in this explanation, feel free to raise it in the comment section. I will address it there. See you guys in my next video where I'll help you with smart solutions to trickier problems. Bye for now.